Hello guys, welcome back to my channel. Myself Subbalakshmi from Sri Venkateshwara College of Engineering. In this section, we are going to see a topic which comes under Mathematical Foundation for Computing, Probability and Statistics. The contents to be covered in this section are Introduction to Curve Fitting, and we'll also see what exactly meant by the second degree parabola by using least square method and fitting the data in the form of parabola and an example problem, and then applications. So what is curve fitting? It is a process of constructing a curve or mathematical function that has the best fit to a series of data points, possibly subject to constraints. The main objective of curve fitting is to theoretically describe experimental data with a model like function or equation and to find the parameters associated with this model. The best fitting curve minimizes the sum of the squares of the differences between the measured and the predicted values. In this we'll see like how to find an equation for a data set, like assuming what model would be the best one to represent the data. It also includes interpolation and extrapolation. So interpolation, which means where an exact fit to the data is required. It also includes smooth function, which is required to construct that approximately which fits the data. In simple words, interpolation means that they want to determine a new value between the existing values. So like we construct a curve through the data points. In doing so, we make the implicit assumption that the data points are accurate and distinct. Whereas the extrapolation refers to the use of a fitted curve beyond the range of the observed data. Like extrapolation indicates a user is trying to find a value in addition to existing values. So the next is second degree parabola. In some engineering, like some data, it cannot be represented in a straight line. So in these cases, a curve is better suited to the data. The least square method, it can be used. So the second degree parabola, by fitting least square method, it is a technique to find the best fitting curve for a data to set up the data points by minimizing the sum of squares of the errors. So the curve, it is in the form of y is equals to ax square plus bx plus c, in which the a, b, c are the coefficients which are unknown, and it can be obtained by solving a system of linear equations. As you can see, the first graph, in which some data points, it cannot be represented in a straight line. So it can be represented by using curve, which is shown in the next graph. As I told, the polynomial function, it is in the form of y is equals to ax square plus bx plus c, in which the a, b, c are the coefficients which are unknown. It can be solved by using the three normal equations. So these are the three normal equations. These are the three normal equations in which the summation, which denotes the summation over all data points, and n, it is the number of data points, whereas the a, b, c, these are the coefficients which are unknown. So let us see by taking an example problem. So this is the equation y is equals to a plus bx plus cx square, and these are the normal equations. So we need to calculate the second degree parabola by using least square method. We are only provided by the x values. So these are the x values and these are the y values. So this is the equation y is equals to a plus bx plus cx square, and these are the normal equations in which we need to find summation of y, summation of xy, summation of x square y, and summation of x square, summation of x cube, and summation of x power 4. So we need to calculate all this by using the table. We are only provided by the x values and y values. So first we need to calculate the summation of x. So summation of x, it is obtained by adding up all the x values will give us a summation of x, and summation of y, it can be obtained by adding up all the y values will give us a summation of y. And now we have to calculate x square. It is obtained by squaring up the x values will give us the x square. So by adding up all these terms will give us the summation of x square. And now x cube, by cubing the x values, will give us the x cube, these terms, and these terms can be added so that we'll get the summation of x cube. In the same way, x power 4, it can be obtained by the x values, and by adding up all these terms will give us the summation of x power 4. And now x into y, so we have to multiply the x with y, will give us these terms. By adding up all this will give us the summation of x into y. And now x square into y, so we have to multiply the x square with y, will give us these terms, and by adding up all this will give us a summation of x square into y. So now we have to apply all these summation values in the normal equation. So by applying all the values in the normal equation will give us the equation number 1, equation number 2 and equation number 3. By using the elimination method, we have to find the value of a, b and c. So first we'll select the equation 1 and equation 2. So the equation 1 and equation 2. So first equation is multiplied with 4, so that the first we can eliminate the variable a. So after eliminating the variable a, we are left out with minus 28b minus 224c is equals to minus 364. This becomes our equation number 4. And then now we'll select the equation 1 and equation 3, so that we can cancel the variable a, and then we are left out with minus 224b minus 1876c is equals to minus 3080. So this is the equation number 5. Now we have to select equation number 4 and equation number 5, so that we can eliminate the variable b. So as I told, we have selected equation number 4 and 5, and we'll multiply the equation number 4 with 8, so that we can eliminate the variable b, and we are left out with 84c is equals to 168. This becomes our equation number 6. And now we have to solve this equation number 6, so that we'll get the value of c. So 84c is equals to 168. Then c is equals to 168 by 84. So we got the c value as 2. And now from the equation number 4, this is the equation number 4, we'll put the value of c in the value of c as 2 in the place of c, so that we'll get the value of b. So minus 28b minus 224 into the value of c is 2. So we'll multiply this. We got minus 448 is equals to minus 364. We'll send this minus 448 into the right side. If it goes to the right side, it becomes plus 448. So we got the b value as minus 3. And from the first equation, as we got the b value and c value, so we'll apply the b and c values in the equation number 1. So we'll get the a value, and we got the a value as minus 4. By solving through elimination method, we got the a value as minus 4, b value as minus 3 and c value as 2. So we have to substitute these values in the equation, as a value is minus 4, b is minus 3 and c is 2. We got as minus 4 minus 3x plus 2x square. So these are the few applications of curve fitting with second degree parabola. So the first is finding the equation of motion of a projectile given its initial position and velocity. So motion of a projectile, it is an object thrown into the air when after the initial force that launches the object, air resistance is negligible and only other force that object experiences the force of gravity. It is called motion of projectile. So it helps us to find the equation of motion of a projectile, and it also helps to modeling the shape of a bridge or an arc. So an arc, it is a typically curved structural member spanning an opening and serving as a support. So it also helps to find some measurements of its height and width and analyzing the relationship between two variables like temperature and pressure in the quadratic pattern. And it also helps to find modeling physical phenomena like projectile motion, as I told, and gravitational attractions, spring oscillations, etc. And then analyzing experimental data and finding trends or patterns, and then interpolating or extrapolating missing or unknown values, and optimizing or minimizing functions like cost and profit. Thank you guys for watching.